Welcome to Instrumentation Academy. In this video, we are going to learn how to read a P&ID. What is P&ID? P&ID is Piping and Instrumentation Diagram. A piping and instrumentation diagram is a detailed diagram which shows the piping and process equipment with the instrumentation and control devices. A standard set of symbols is used to prepare P&ID, and these symbols are based on International Society of Automation. Importance of P&ID. P&ID is used for identification of components in a process plant. It shows how instruments are connected and where they are located. It also shows the functions within the process. It is used for plant construction and process monitoring, and also for troubleshooting in the plant. This picture shows a part of a process plant. The P&ID of such a plant will be like this. Now let's discuss some important things to note on a P&ID. On a drawing, thick continuous lines represents pipes. When two lines cross over or make a corner without any break in drawn line, it means that those two pipes are actually connected in the plant. If the drawn lines cross over each other but show a break or gap at the crossover, it means that pipes are not connected in the plant. A P&ID shows the direction of a fluid stream flowing within a pipe. The direction of flow is drawn as a solid arrowhead on the line representing the pipe. Revision clouds and revision triangles. There are two common methods of indicating revision changes made in a drawing. The first is cloud method, where each change made in a drawing is enclosed by a hand-drawn cloud shape. The second method involves placing a triangle with the revision number inside it next to the portion where revision changes are made. Many drawings are needed to represent an entire plant. So, a method for showing where a pipe goes next appears in every drawing. That is the process flow tag. This symbol shows from where the pipeline is coming and the previous P&ID drawing number. This symbol shows to where the pipe is going and the next P&ID drawing number. Tie-in or termination point. New work in a plant that joins to the existing plant is represented with the termination point. The piping hazard level rating. This symbol shows the hazard ratings according to the product in the pipe. This figure shows the main hazard level ratings. Hazard level B indicates the pipe which carries medium level hazard product. Hazard level C indicates the pipe which carries low level hazard product. And hazard level E indicates the pipe which carries negligible hazard level product. Now let's move on to instrument symbols associated with P&ID. A circle with no line in it represents an instrument that is physically located somewhere in the field. This figure shows some field-mounted instruments. This is how a field-mounted instrument is represented in a P&ID. Circle with single horizontal line. This represents instruments that are mounted on the control panel. This is how the control panel mounted instruments represented in a P&ID. Circle with double horizontal line. This represents instruments that are mounted on the sub-panels or remote locations, and this is how they are represented in a P&ID. Circle with a single dashed horizontal line. This represents the instruments that are mounted inside or backside of the control panel, which are generally inaccessible. These are the symbols associated with instruments. If these symbols are enclosed within a square, it means that they are a part of DCS control process. If the shape of the symbols are diamond enclosed within a square, it means that they are a part of PLC control process. When you spot one of these symbols on a P&ID, you will be able to understand three things from it. Number 1, what is that device? 2, where is it located? And number 3, why is it there? The what and where aspects can be determined by the symbol shapes. The Y part comes from the text placed inside the symbol. This text is known as instrument tag number. Instrument tag number. Instrument tag number is an alphanumeric code that provides specific information about an instrument or its function. Instrument tag number has two lines in it. One is upper line. It is a short form for functionality that instrument provides. The second is lower line. It is a loop number that corresponds to the equipment in the plant. Since most plants have many instruments of same type, the unique number is applied so that each one can be individually identified. This number is known as loop number. In this instrument tag, the first letter in the upper line indicates the type of process variable the instrument is used for. The succeeding letters are used to represent the function of instruments. The lower line represents the loop number. Local indicating device symbols in P&ID. Local indicators shows the measured value in the equipment and process lines. This figure shows how primary indicating devices are shown in a P&ID. Transmitting device symbols in P&ID. The transmitters send the measured value to the control cabinets, allowing us to control and monitor the process. This figure shows how common transmitters are represented in a P&ID. Valve symbols. Valves are used to control the direction, flow rate, and pressure of fluids. This is a symbolic representation of different types of valves in a P&ID. It should be noted that globe and gate valves will often be represented by the same valve symbol. In such cases, information concerning the valve type may be conveyed by the component identification number or by the legend section of the drawing. Valve actuators. Some valves are provided with actuators to allow remote operation and to increase mechanical advantage. The combination of a valve and an actuator is commonly called a control valve. Control valves are symbolized by combining the appropriate valve symbols and actuator symbols. This figure shows the P&ID symbols for the common valve actuators. Although each is shown attached to a gate valve, an actuator can be attached to any type of valve body. If no actuator is shown on a valve symbol, it may be assumed that the valve is equipped with a hand wheel for manual operation. Control valve designations. A control valve may serve any number of functions within a fluid system. To differentiate between valve uses, a balloon labeling system is used to identify the function of a control valve as shown in the figure. The common convention is that the first letter used in the valve designator indicates a parameter to be controlled by the valve. The second letter is usually a C and identifies the valve as a controller, and the third letter is a V to indicate that the piece of equipment is a valve. Line symbols. The piping of a system may contain more than a single medium. These are the symbols used for indicating the medium carried by the piping and for differentiating between piping, instrumentation signal, and electrical wires. The most common line type is solid line, which is used to represent main piping. Instrument line or impulse piping is shown by a thin line. A line with short dashes represents electrical signals. A line with long dashes means the pipe is existing in the plant. A line with short double slanting lines represents pneumatic signal, which is the instrument area to control valve or devices. Line number. Every pipe on a P&ID requires a unique number so that it can be uniquely identified during design or referenced in operating procedures. Line number is a unique number assigned to every line. Line number has basically 5 parts. First part is line size. It represents the size of the pipe. Second part is conveyed fluid. This is the service code for material that normally flows in the line. The third part is pipe area code. It is a unique number based on the pipe location in a plant. Fourth part is pipe material classification, and the fifth one is insulation code and thickness. Now let's see an example of line number. In this line number, 3 represents line size. KE represents conveyed fluid. 1006 represents area code. CD121 represents piping material classification, and the last part represents insulation type and size. So by this we come to the end of this video. The rest we will discuss in the next video. If you like this video, please support us by subscribing our channel. Thank you. Have a nice day.